Hey everybody, quick video here and then a time lapse of this thing printing. So 3D printing. I do some 3D printing. I designed my own 3D printer. Show you that real quick. It's working on a print right over here. Set at a height that is reasonable to look at it. And you can see that there. Turn the light here so it's pointed at it. It's a 3D printer. It prints stuff in 3D. It's working on a test piece for a new design of this LPG tank that I'm going to post online that other people with 3D printers will be able to print. It's designed to print well, it's designed for the type of manufacturing it's intended for. I've got a lot of experience with that and with design for manufacturing, various forms of manufacturing. Not a lot compared to some people that work in specific industries, kind of generalist, have just dabbled in a lot of different things. But I do have experience with it, and I have my own 3D printers, so yeah, for 3D printing I have a lot of experience. Anyway, that's working on that, and it's going so well that I'm probably going to stop it and print the actual object instead of the test piece, which is actually midway up it, to try and see if it'll print some of the particular details that I want to focus on correctly. If you 3D print, this is the video for you. If you 3D print and you are an N-scale model railroader, HO, it'll apply as well, and HO guys have it easier because it's larger and it's easier to get good details out of a less precise form of manufacturing. Anyway, that's a 3D printer. It's working away. Let's go back to the 3D print compared to a Walters kit. So, down here, zoom out, we have a Walters North Island refinery kit that I just have finished up to a level. Sorry, I'm going to get the camera at a level that's really best for you guys to view this. I think that'll be that, right there. And then I can bring these in, turn the light on them, and really get a good idea of what's going on here. So, one thing about the North Island refinery kit, if you compare it to other buildings and structures, it's a little small in all its scales. Here is an unpainted Walters office, and we'll put it next to, this is from the gas resale place, or gas retail distributor. It's like a gas supplier that comes with like 3 long tanks with rounded ends that are LPG tanks. I haven't put those together yet. Anyways, you can see, compared to a normal refinery, this building's a little small, or I mean a little big, and the refinery's a little small. And if you put these guys, these are from one particular these are Notch, I believe, N-O-C-H-E. Look at this guy up here, and he looks big. The railing's just a little low. It should be higher than his waist. He's got a risk of falling over that thing, and he's just a little big for it. But then here's a guy from another manufacturer up there. My fat fingers. And he's much smaller. See, he's like a rail fanner or a photography. He's from, I think he's photography. Oh, come on, camera. Okay, so he looks a little better up there, but the railing is still low. So, I'm probably gonna have to find figures that look right, but it's okay because you just gotta find the right figures. The refinery itself should go in the background, and then this way it kind of gives you a forced perspective effect where it is slightly smaller than like 1/150th, but it'll make the scene look deeper if I position it correctly. So that should be okay, even though these guys don't really fit. But it's something to think about when you're modeling your own stuff and 3D printing it, or if you're 3D printing, a lot of times you're scaling things that you find online, or you have the ability to scale them at least before you print them. And that's something you definitely want to think about. So for my 3D printer, it's pretty accurate. I've worked hard to design it to make it accurate. And I can do railings and stuff, and they'll be included with what I post online. They print flat, so you have a chance of printing them. The ladder, the railings, the vertical grid structure, all that prints as parts that you glue together. You don't just print it all at once, because then it would be difficult. It would only really, really well-tuned printers would be able to do it, and it would take the best filament, and it would make a lot of people frustrated, and they'd be struggling with their printer. I'll do another update on, I'll do a video, not an update, but I'll do a video specifically on the theory of 3D printers and how it applies to model railroading for both types of printers that are accessible. FDM, plastic extrusion printers, and resin-based printers that are printing basically an HD image a slice at a time. Call it tomography in scientific fields. We use it for like medical scanning and all that, but it's basically the same thing but in reverse. You take the image that's in multiple slices and then create each layer. So I'll get into all that in another video that's specific to what you want to look for N-scale modeling, because I know a lot of people are into N-scale railroading and they're like, yeah, I love modeling and fine detail, but they don't understand manufacturing theory with additive machines, where the machine adds material to create a form. I've done machining with mills and lathes and done subtractive manufacturing and made very precise objects, and I've done additive manufacturing for structural objects and for decorative objects, and so hopefully I can help the novices out there. I know there's tons of people that are better at this than me, and there's a lot of people that don't have as much experience, so I'll just hopefully the information I give will be of use to some people, and you know, if you're more advanced on these subjects and you know more than me, then you can post that info in the comments and further inform the community, and we'll all be better off for it. So anyway, this is an LPG storage tank for like a facility, a chemical facility, a refinery that's manufacturing liquefied gases, some sort of, you know, air gas facilities have these for cryogenic storage of all kinds of stuff, helium, argon, oxygen, whatever. It's just holds stuff that's under high pressure and is cold, and so anyway, and to get those kind of things that are normally gas at normal Earth atmospheres, then you got to go cold and add a bit of pressure to get it to be a gas, store a bunch of it in a small space. So you guys know what I'm talking about. You want these things in these facilities that your trains run through to make it look super cool, and hopefully this will fit the bill. It'll be much better once it's painted, but I wanted to compare it to the Walters kit because I was struggling. I was worried about the detail of the railings and all that, but these railings are actually more detailed in some ways than the Walters kit. They're smaller. The Walters kit are kind of bulky, being injection molded plastic at the detail that we see on like scale trains and Athearn freight cars. It would just be so fragile, so they're using, I think, photolithography to like cut metal in fine detail, but that those plates of metal cut then just hold that better. I'm wondering if they could accomplish the same thing with like a wire bending tool for like some things. I mean, heck, a staple gun actually bends a nice little piece of wire for something at N scale pretty well. You could make a railing just out of popping out staples bent from a staple gun without putting them in anything and lining them up. There's your railings. So there's manufacturing right there for N scale. But anyway, for these things, for my use, I was worried about the scale of the railing. So I measured this guy, he's about 12 millimeters. I've got a good machinist's measure here, metal ruler with precise marks for millimeters, and this guy's coming out at like around 12 millimeters, 12 and a half. And these railings seem to work. I'll just lower the camera down so you guys are all at the N scale world height, looking at it from your office because you're like the owner of the refinery. Okay, so that looks okay to me. Those railings, it's like they're small enough. They printed okay, not the smoothest, but I'll improve that. I was actually cold extruding. I didn't have enough heat going on in the filament, which is why the surfaces are so bad, but I figured that out and fixed it, and I'm doing much better. It makes for more stringing that you have to clean off, but I'd rather have stringing that I clean off at N scale than a truly messed up surface where it hasn't extruded enough. So, in a future video, all that'll be discussed as far as the theory of tuning a filament profile for a 3D printer. A lot of it is going to be specific for FDM 3D printing, which is the kind where you're extruding plastic with heat. I'm just getting into SLA resin-based 3D printing, but I'll post some videos on that as I go. But there's going to be a lot better sources because I have looked into it, but I haven't done it. I've actually done powder bed printing in college, which is a more commercial, industrial form that gives really nice results, but it uses a massive amount of material. It's just different, and the machines are more expensive in the thousands of dollars, and it's not the kind of thing you do really at home or for a hobby, but it gives really nice results because it's melting powder in fine layers with a laser that's really precise. So anyway, there's my LPG tank that I'll be posting online that other people can print, but that is going to be a different version with smaller legs, a grid work between the legs. That's either going to be separate models that you print and apply in there, or it'll print. It's going to be based upon both how my printer does it and what I expect the average printer will do. I mean, if you have a Prosa i3, you can print just about anything anybody can print. Those are really nice, and then you'll have no problem with it. Mine's going to be designed for the bought it on Amazon kind of $200 range FDM 3D printer, with the person getting a basic idea of a filament profile from other sources online, like just what the manufacturers recommend as far as temperature and print speed, and then what people recommend for the printer itself that they have. But it'll be designed so the print parts eliminate issues with stringing and issues with overhangs and things like that, because I like to print things that are easier for my printer to print than struggle with having to reprint and retune a profile for a particular plastic specifically for the object. And I find that you can separate an object, a model, and it will just make it a lot easier to print. Like these things, it's separated into two different halves to print, because that way you get the same surface quality on the top and bottom. Here's one that I stopped to print because I was getting that cold extrusion. If anyone wants to see what cold extrusion looks like, it's just not putting out enough material to make the feature. But it actually, these islands, it's doing it on one of them is better than the rest, and that's where it's starting out and starting to print this, but it's just a little too cold, and there's just a little too low on the extrusion factor in the slicing software, so it's not putting out enough material. And this one looks okay, and then it gets worse and worse and worse, and then you come around, it's going around this way, printing those. It's like printing this, and then it goes over here, and then here, and then here, and here. By the time it gets to the end, it's lost ground. It doesn't have enough material in the manufacturing machine coming out at a fast enough rate to keep up with what it's trying to do. and it's getting spotty results, just sputtering. So I need more heat so it flows through the machine quicker and easier with less resistance. And actually, instead of going slower, I'm going faster. That'll eliminate some of the stringing by breaking the string as it travels between points, trying to print each one of these. And it'll help with that super hot material to actually push it out at the right rate. I'm going to have to experiment with that. But think of, with a plastic extrusion printer, it's kind of like printing with a garden hose. If the water came out and landed and instantly solidified into an object, like I guess you could do that if it was below freezing outside. You could 3D print with your garden hose if you could put some insulation around the hose so that the water came out and it didn't freeze up, you know, back to the spigot. And that would be an interesting video. Someone should do that. But in any case, you got your water coming out, and if you have the flow on really low, it'll dribble out, and it won't be in what looks like a solid stream and is mostly water comes out from a pressurized nozzle like that as individual droplets. It just does. It separates as air pressure as it's falling separates it. So if you have that garden hose really close to like a cement surface, you could get a solid stream. But to do that, at a low enough pressure, it's going to drip out. It's going to bloop, 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 bloop. And then at a certain amount of pressure, it's going to reach the edges of the nozzle, and it's going to come out with laminar flow and be a solid stream. And then if there's too much pressure, it's going to start to depressurize as it comes out and sputter out the side. So you want to be, with a 3D printer, it's kind of the same thing, and you want to be in that sweet spot where it's coming out without dribbling, but it's not just too fast and too hot and expanding out and making a really rough model. So tuning that is how fast you're printing, how fast the extruder is extruding the plastic, how hot the plastic is as you're extruding it. All those things factor into tuning a filament profile to get a decent looking object. And it's all within, tenths of a degree Celsius matter. Mainly I tune in 1 degree Celsius, up or down. I think that's a solid fine tune range. And then if you're trying to settle in on a number before you get to the final number, maybe tune in like 2 or 3 degrees Celsius up or down to get closer or farther to the results you want on a test object where you're not printing the whole thing. So anyway, yeah, drifting into 3D printer theory, which I really want to keep to a separate video and just make this about, LPG tank will be coming soon, and at the end of this I'll put the time lapse in there, which should only take a few minutes. So we'll just cut this short with saying, the Walters North Island went okay, finally got it done, just did other million things after I'd kind of half completed it. But it's cool, and an FDM printer with a 0.4 nozzle will print to N scale for building details and stuff. You got to work at it as far as the design of the model, or whoever made it has to, and it needs to be separated into parts and thought through with a mind for the N scale model as a final result, and the intricacies of whatever printing process is going to be used, because gravity is not your friend when you're trying to 3D print. Supports, I try to make supports irrelevant to the object. That's why I cut it up into sections. It's also much better if it's cut into sections. If your printer is doing something weird and it fails, it's better to fail on one little part of a model than on like a 10-hour print that's the entire thing. That wastes a lot more time. I like 2-hour prints. When it gets done, you can see the results. If it's worked out, then you can move on to the next part of the model, produce that, and have a model that's fairly easy to glue together at the end without having to risk having something go wrong at the end. I've had things go wrong at the end of like 18-hour prints, and that's just like, it's just let the machine run for 18 hours. It's used up a ton of material. Sometimes it's not cheap, and now the print's failed like right when it was almost done, but part of it looks like junk. So yeah, I like to section things up into smaller parts, which is why halves, quarters, thirds, and things like girders and small details printed flat, where it's just printing it flat, because then it has the best chance to make it look good as well. You can just print it flat, glue 4 sides together, and you're good to go. It looks like you have a vertical structure, and there's no stringing from it trying to print individual little tiny islands and then pop over and print another one, and that just gets, you get into all kinds of trouble as far as needing really good cooling, and just there's issues. It can be done. I've tried to print stress test objects that are just all kinds of little fine details, and I've tuned filament for days to produce them really good so that I could post it online and be like, hey look, I did it, and people are like, hey wow, that's cool. But to get that object, there's better ways to go about it. As well as these objects will be separated so you can paint the individual different things that would be different materials fairly easily. That's another thing that is totally not functional with printing the thing as one piece. If you print it as one piece, then there's just all kinds of nooks and crannies that you've both got to clean out, little stringy bits of plastic if it's strung in there, or supports if you're doing resin printing, as well as then there's just no way to get paint back in there. So yeah, my models will be for the modeler, not for the 3D print kind of fan that wants to see just how hard they can make it on a 3D printer versus how, mine will be how easy can I make it on the modeler that owns a 3D printer. So hopefully you guys like the stuff that comes down the road in the next couple weeks and months. This should be done in the next week. It's not going to take more than a week, probably in the next 2 days. Get a model out there, because I've done a lot of design thinking on it. I've got all kinds of stuff on the computer that that is ready to go. I'm working on the final model, and when that's done, it'll be posted online and you can download it on Thingiverse, and if you have a 3D printer, you'll be able to have it. So real quick, we'll take a look at that screen of the computer, and I'll turn the light away so you're not looking at just monstrous glare. Okay. So here's my workstation for doing design work, right in front of the railroad, right in front of the port facility. But in any case, where's my pointer? Okay, so here's Fusion 360 interface. This is a good software. You can get a trial version, you can get a startup version for free. I went to industrial design college and trying to get into the world of industrial design, but I gotta do it freelance, kind of from home, because I got some kind of serious health issues right now, but they are getting better, so no tears for me, and let's not worry about that or focus on it, because they're getting better. So you woohoo and right on, and let's just talk about this. This is a 3D model of that tank, a new version, thinner legs, grid work in between, in there. I'm going to zoom the camera in so you guys can see it better. If you got a small screen, that'll work. Okay, so it's done in sections. Railings, you'd print them flat and show like just that. Which body is that? Sorry, looking for this. This one, get rid of, and then zoom in to those laptop viewers and get rid of the ghosted blue, and you can see it's just one thing. And if I got rid of the stuff around it, you could see that just that would be printed as a single object flat, and that just is way easier on the printer and on the person, because stuff like that near the top, I mean, if it fails in the print, if this is one object, it would just be ridiculous. That would be like 6 or 7 hours into it, even if you had a pretty fast printer, and you'd just be bumming. You'd just be like, oh no, and why did the person put that model online instead of one where I could print those separately? Well, I'm not going to put you through that. These will be separate so that You'll be like, great, I got the top part, it printed well, I can print the bottom part. If it doesn't print well, you can try again, but you still got the top part that printed well. And in that way, you won't be wasting your time and your materials and costs. So anyway, yeah, that's what I meant by all that. And that's that object there. And then here's a part of it over here in this software, which I use S3D, which costs a bit of money, but Cura is actually really good slicing software to use. So let's turn the screen a little so you're looking at it flat. And this is a slicing software, and that the red part of the travel moves. Normally you don't look at them. Let's get them out of the way. Now you can see the object without. Those are the red things are the paths of the printing head, which is the part of the machine that extrudes plastic as it's moving in free space in between actually printing stuff. The green is all paths that the printer is printing, and we can reduce it down layer by layer and see the individual layers that the printer is printing. Let me turn this so you can see it on screen a little bit better. Oops, I zoomed it out. Let's move it up. Let's twist it so you can see those shadowed edges, so you can see the 3D object really clearly, and then I'll go through that again. You can see the layers in the slicing software that would happen, and you can see the individual little paths that the machine takes. So where it is now, that's where it's going to start printing each layer, where that gray bar is. That simulates the print head of the machine, and it's always going to start over there on that spot. And I've actually set it to start as close to 0, 0, X and Y, which is the center. This is Z right here, this blue thing in the middle. That's the Z indicator. X and Y are, on the, the horizontal plane. And I have it started as close to this point, so it'll always be starting on the inside is where it travels to. That way it keeps all stringing to the inside of the model, in between all these legs, and I'll be able to clean it out and hopefully it'll look okay if there is any stringing. Anyway, so this is a slicing software for FDM printing. That's the model, and those are the paths that the printer will take making this object. It's the bottom half of this LPG tank, and then just actually process this, I click on the Save Tool Paths to Disk, which tool paths are what a CNC controlled machine, regardless of its additive or subtractive, like a CNC mill that carves out metal or wood and makes an object, uses tool paths as well. And these slicers apply to those as well, although what you'd see on the screen is it'd be a bit different. I've already saved that, so I don't need to worry about it. But exit the cancel, exit the preview mode. You can see the object there, and actually this one that was set low in the table to just do a test of this particular junction where these fine details come out. It's printing up from the bottom, and so it starts to have to print these 45-degree angle supports. Actually, they're a little more than 45, and that's a little more difficult job for the printer. And so I wanted to see how that went, and you actually can see the results of that over here. I'm going to move the camera and I'm going to move it down. It's going to be a little confusing. Hold on, don't worry about it. Bear with me. You'll enjoy the results because you'll see what's happening on the machine after viewing this. So here's the machine is operating. That little gray bar was that print head, complicated device with electronics on it, sensors, temperature, and infrared distance sensors. And there you can see those little angled supports printing, and there's some stringing. You can see there's areas that I don't want to be in there that are in there. I think one of the worst is right there. I'll grab an object I can point with. that's not the same color as everything else. There we go. Aluminum tubing. So right in there is a bad bit of stringing, but I could remove that. And because it's so solid, I think it'll actually remove very sightlessly, because the solid part's up at an angle out in free space, and it's started to gather any plastic that's happening there extra. That's actually helpful. It's actually might remove very easily. And it looks, some of them are coming out fairly clean, but there's some issues. They could be fixed up with a little filling material, but still, I think I might want to tune this a little more. I think I'm going to stop this print and tune the profile a little bit better to try and get a little bit better result, a little bit cleaner model. But the surfaces of the material, this is just a string, it's not there, it can be removed just by hand. And this surface is actually looking pretty good. This flat surface of the sphere and the ridges where the panels are welded together, that's all looking pretty good. And you know, hopefully this, for the people that are novices with 3D printers or thinking about getting one, it gives you an idea what goes on with a plastic 3D printer and an N-scale model for a layout that one is designed and is making in their home. And I've printed a lot of objects, and if you went on like the review channels for 3D printers and stuff, I think they'd agree those little support pillars, those angles, that's kind of extreme for a FDM printer. But it's possible, and like I was saying, like the better quality 3D printers you can buy out of the box, like the Prusa, if you're going to spend, you know, over $500 on a 3D printer, just get a Prusa i3 MK3 or whatever it is, the newest one, because that company, that guy has been at it for a long time, and all the other companies are using stuff that he figured out and taught the community, and then they make use of. So if you're extruding plastic to, you know, to make models, and you got the money, a Prusa is what you should be looking at. I hope you guys enjoyed the view of a 3D printer at work and what you can expect and what you want to think about, you know, when you're designing these objects for your railroad to get a good looking N-scale or HO scale object. And N-scale features, I'll be throwing them at you. My models will be available on Thingiverse. If I change the distribution website, I'll let you know. And like I said, I went to school for industrial design, for product design, so small little products like this, it's right up my alley. Hopefully this will work out. Should be fun. I hope people enjoy it, and I hope they find the information useful that I provide. If they've got their own 3D printer and they're, you know, trying to get things manufactured. I've been thinking about it for about 8 to 10 years. I've been thinking about small scale manufacturing, and 5 years 3D printing, and seriously thinking about that. Although I printed at larger scales. I printed at like hand size and like, you know, home product scales, like making things for people's kitchen or bathroom or just around the house, and stuff like that. And N scale is extreme detail. 1 to 150 is tiny, and things are small, and that's rough for a plastic extrusion 3D printer. Resin printers have a better chance of it, as people that are more into this well know. But still, I'm going to be able to make it happen for the people with the average FDM 3D printer with a 0.4 millimeter nozzle. I'm thinking of going to 0.2, but for now I'm printing with 0.4, and I'm going to keep a machine running with 0.4 for the larger stuff, and my models I'll always, you know, be thinking about the people that have that basic machine, because I've seen on Thingiverse and other websites there's not a lot of N-scale stuff, and some of it prints okay, but it still takes a pretty finely tuned machine, and hopefully the stuff I put out there will be thought through so that people will be able to easily assemble a basic model that looks good at the end, that has the details that we're looking for. You know, maybe not, it's not going to be scale trains details, but it'll be, you know, to the Walters kits and stuff level of details in a lot of cases, and hopefully everyone will be real happy. So anyway, this is dragging on. I'll try and edit it down, but 3D printing is a complex subject, and I'm just kind of getting into offering my thought process and skills to the community, and there you go. It took me 37 minutes, 38 minutes thereabouts to train it down a little bit, but anyway, happy modeling. Take care. Cheers, John.